So today we'll learn about the solution of linear programming problem. So the first method of solving the linear programming problem is your graphical method. So using graphical method, how will you find out the solution of the given linear programming problem? So as all of you are aware with the inequation solution that you have got in class 12 itself. So let me explain the thing how to find out the solution of linear programming problem using the graphical method. That is very simple. First, what you need to do, as you know, your in the general form of linear programming problem is optimize z is equal to objective function, that is, say it is ax plus by suppose this is your what objective function, and you have to optimize it. That means either you have to minimize or maximize, depends on the problem, and subject to the constraint, say it is suppose it is a1x plus your b1y, say less than is equal to say c1. Say next is your say a2x plus b2y less than is equal to say it is c2, and then there is a non-negative restriction over the variable, that is x and y should be either greater than 0 or equal to 0, that is positive. Now the first step is what? If your given problem is not given in your mathematical form, if your given problem is not given in your mathematical form, then the first step is to formulate it and write the mathematical form of the given linear programming problem, and that I have already discussed in the last 2 classes. Then the second step is what? Second step, in order to find out the solution of the your LPP, the second step is what? Whatever with the constants. So all the constants are what? Are of type inequations. Then what you need to do in the second step, convert all inequations in terms of what? Equations. That means here what you need to do in the second step, this inequation a1x plus b1y, this was your inequation, less than is equal to, so that's why it's the inequation. So you have to convert in terms of equation, so put equal to c1. Similarly, all the constants you have to convert in terms of equations. So next is your a2x plus b2y is equal to what? c2. Okay, so this is your second step. So second step is what? convert all inequations in terms of what? Equations. So this is the second step. Next, the third step is what? You need to plot all these equations. You need to plot all these equations in the graph. So just because all are lines, because the linear equations are there, so all represents line, and so draw this line over the graph. After drawing the graph of each line, the next step is to find out the region. Next step is to find out the region. So in order to find out the region, what you need to do? What you need to do? Put x is equal to 0, and then you put y is equal to 0 together in each inequations. Try to understand. After drawing the line on the graph, next you need to check the region. So in order to find the region, what you need to do? You put x is equal to 0 and y is equal to 0 in each inequations. In where you have to put in each inequations, and then you need to check whether that inequation satisfy this origin or not. That means if you have an inequation like this, 2x suppose minus suppose 3y is less than is equal to suppose 2, and another inequations like suppose 3x minus or plus y is greater than is equal to 1, say 1. So suppose you have these two inequations. So what you need to do, you check the origin, whether in the solution region of each line, whether origin is there or not. First thing, you need to find out the region for each line, and then we need to combine that region. The common region we will take. So first you need to find out the region for each line. So how will you do? Put x equal to 0 and y equal to 0 in each inequations. So first, if you put here, if you put x equal to 0 and y equal to 0, so this will become what? Left side becomes 0. 0 is what? Less than is equal to 2. So is this statement is true or not? Whether 0 is less than is equal to 2 or not? Huh? Whether 0 is less than equal to 2 or not? Obviously, 0 is what? Less than is equal to 2. That means the solution region of this line contains what? Origin. That means in the solution region of this inequation contains what? Origin. Origin will be there. Similarly, if you put x equal to 0 and y equal to 0 here, so it will be what? 0, left side will be 0, greater than is equal to what? 1. Greater than equal to what? 1. So that means what? Is 0 is greater than equal to 1? Obviously not. That means in the solution region of this inequation, origin will not be there. That means in the solution region of this line, origin will not be there. So like this, we need to find out the solution region for each and every inequation. So after finding the solution region for each and every inequations, what you need to do? In the next step, we need to find out the common region. What you need to do? We need to find out the common region. And then this common region will not nothing but is the feasible region of the given LPP. The common region which you will get, that represents the feasible region of the given LPP. Then from that common region, what you need to do? You find out each corner points. Try to understand. After getting the common region, that means feasible region, you need to do what? You need to find out each corner points covering this common region. And then you find out the coordinates of each point, each corner points. And then in the next step, what you need to do? You need to find out the value of what? You need to find out the value of this objective function z at each and every corner points of the surrounding the what? Common region. Again, I am repeating. What you need to do? After drawing the graph of each equations, these equations, you put x equal to 0 and y equal to 0 in each inequations, and this will give you whether origin will be in the solution region of the given line or not. After finding the solution region for each and every inequations, you will get a common region. You will get a what? Common region. Then after that, you need to find out the corner points of that common region. That means the feasible region. You need to find out the corner points. And then what you need to do, at each corner points, you need to find out the value of what? Z. You need to find out the value of Z. So after getting the value of Z, different values you will get of Z. So now see what you need to do about the objective function Z, whether you need to maximize or minimize. If your problem is of maximization problem, then whatever be the values of Z you have got at each corner points, you need to check at which point you got the value of Z as maximum. You got the value of Z as maximum. Similarly, if the problem is of minimization, then you need to check at which corner points you got the value of Z as minimum. And that corner points will give us the value of what? X and Y, and that serves our purpose of finding the solution of the given linear programming problem. So this is all about the method of solving the what? Linear programming problem using graphical method. Now let's see one example that will be you get more clarity from that example. So let us see this example. So the problem is what is it's already given in the what in the mathematical form, so no need to convert. So step 1 is over. So step 2, next step. So this is your what? Objective function, and the objective function, what you need to do? You need to maximize it. That means maximization problem. And this is the constant, and this is the non-negative restriction. So step 2 is what? First you need to convert. This inequation in terms of what? Equations. So we have converted this in terms of what? Equations. Or non-negative restriction also you have to convert into equations. X equal to 0 and y equal to 0. So you got the equations. So we have 4 equations. We have how many equations? 4 equations. Now these 4 equations you draw on the graph. So in order to draw this line, what you need to do? So as you know, to draw a line, we need 2 points. So very simple, what you do? In order to draw this line, first you put x equal to 0. you will get the value of y. From that, you will get the value of y. So how much y? If you put x equal to 0 here, so y will be what? 15 by 5 is 3. So y is 3. Then next you put y is equal to 0. Then you will get the value of x. Put y equal to 0. So x will be how much? It is x equal to 5. Simple. Once you put x equal to 0, you will get 1 point. Once you put y equal to 0, you will get the other point. So you have 2 points, 0, 3 and 5, 0. Just you plot on the graph and then you join the 2 points and extend on both sides. Extend both sides the line. So you got the first line on the graph. Similarly, the second line. Second line, if you put x equal to 0, if you put x equal to 0, you will get what? Y equal to how much? X equal to 0, so y equal to 5. Y will be 5. Then you put y equal to 0. Put y equal to 0. You will get the value of x. Y is 0 means x is what? How much? 2. X is 2. So you got the 2 points. Just you plot on the graph and then you join and extend on both sides. So you got the line. And x equal to 0 what? Which line? X equal to 0. That is your y-axis. And y equal to 0. That means your what? X-axis. That means your solution region will remain in where? In the first quadrant. Because if this is your y-axis and this is your x-axis, if this is your x-axis and this is your y-axis, so over x-axis the y coordinate should be 0 and over y-axis x coordinate should be 0. So if x equal to 0, x equal to 0 means which line? Y-axis, and y equal to 0 means what? X-axis. So that means your solution region will lie here in the first quadrant only. And obviously, as you have already got in the last class, as already have discussed, the values of x and y can never be negative. Can never be negative. So that's why you will get the solution region in the first quadrant itself. Now, next step is what? After drawing the line, what you need to check? Whether in the solution region of each inequation, whether origin lies or not. So for that we need to check. So we need to put x equal to 0 and y equal to 0. So if you put in the first inequation x equal to 0 and y equal to 0, so left side will be 0 and 0 is what? Less than is equal to 15. Right side is your 15. So obviously it's true. 0 is obviously less than is equal to 15. So that means in the solution region of the first inequation, origin lies. Similarly, in the second inequation, if you put x equal to 0 and y equal to 0, so 0 is what? Less than is equal to 10. So 0 is what? Your less than is equal to what? 10. And that's also true. And that means in the solution region of the second line also, in the solution region, origin lies. That means in both the inequations, to their solution region, origin lies. So next, what you need to do? So just a minute. Now see here. This graph. So this is the two lines. Try to understand here. This is the line 5x plus 2y plus 10 and equal to 10, and this is the line what? 3x plus 5y equal to 15. Okay. So these two lines are intersecting. Okay, no doubt. Now see this line. See this line. This line. Now, as already you have verified that in the solution region of both the lines, origin lies. So now see, so just you forget about this line. 5x plus 2y equal to 10. Just you forget about this line. First, you need to check the solution region of this line, 3x plus 5y equal to 15. Now, as already you have verified, in the solution region of this line, 3x plus 5y equal to 15, origin lies. Because 3x plus 5y, if you put x equal to 0, your in equation was your what? 3x plus 5y is what? Less than is equal to 15. So when you have substituted x equal to 0 and y equal to 0, so 0 is what? Less than is equal to what? Less than is equal to 15. And so that's true. And that's why the origin will lies in the solution region of what? This line, 3x plus 5y equal to 15. So origin is where? Origin is here. That means the solution region will be what? To the downside here. The solution region of this line will be what? Here, this downside. All the solution region. So solution region will be what? Downside. This will be the solution region. This is the whole solution region of this line. Its opposite, if suppose in place of your less than is equal to, if it has been given greater than equal to, if in place of less than is equal to, if it is given greater than equal to, then 0 will be what? Greater than is equal to 15. And this obviously this statement is not true. And this statement is not true. That means in the solution region of this line, this inequation, origin will not lie. So then in that case, the solution region will be what? Above the line. Then in that case, the solution region will be what? Above the line. So this is the thing you need to verify. You need to check. If origin lies, so below the line, the solution region will be, and if origin, if the inequation does not satisfy the origin, then origin will not lies. Then in that case, the solution region will lie above the line. That is the thing you need to check. So here, since in our inequations, this is less than is equal to 15 is given, and so 0 is obviously less than is equal to 15, and that means the solution region will be what? Solution region will be below the line. That means that contains the origin. That contains the origin. So now next what you need to do? The same thing you need to do with the what? With the line 5x plus 2y is equal to 10. This line, about this line. Same thing. So here 5x plus 2y is less than is equal to 10 is given. So if you put x equal to 0 and y equal to 0, so 0 is what? 0 is less than is equal to what? 10. So in the solution region of this line also, what? The origin lies. That means this is the line. So below the line. So that means the solution region will be what? This one. Solution region will be this one. Solution region will be this one. This is the solution region of this line. So we have drawn all the lines, all the 4 lines. X equal to 0 means y axis and y equal to 0 means x axis. And the 2 lines, this all. So all lines I have drawn. Now the next step is what? We need to find out the common region from that too. So we have drawn both the regions for both the lines. And then from there you need to find out the common region. So obviously, if you see, this line, this part, this part will be common. This part will be common in both the solution region. Because if you take this part, so this part will not in this line. This part will not be in this line. You can't take that one, and you have to take the first quadrant part only, because the negative axes are not considered here. So always the solution region lies in the first quadrant itself. So this is the region. This is the common region in the first quadrant. So this, okay. So now next what you need to do. So this is your common region. This is your common region. Now next you need to find out all the corner points. After finding the feasible region, this region is what? This region is called the feasible region. This region is the feasible region. Then after that, you need to find out all the corner points. So what are the corner points? Corner points are, these are the corner points. First corner point is this one. Then here one corner point, this one. And this is the origin. This is the another corner point. So that is not required. Then this is the another corner point. So we have how many corner points? 1, 2, 3, and 4. So this corner point is obviously it is 0 origin, and this corner point you'll get from x-axis, and this corner point also you'll get from y-axis. Now this corner point. So this corner point is nothing but the intersection of what? Intersection of this line and this line. So just you solve these two equations, you will get the intersecting point. So this is the point. This is the coordinate. This is the point. Next, what you need to do? Once you got all the corner points, you need to find out the value of z at each corner points. And then since the problem is a maximization, then you need to check at which point, at which corner points you are getting the value of z is what? As maximum. So we have done that one. So at each corner points, we have got the value of z. We have got the value of z. So see here, at origin, obviously it will be 0. The value of z will be 0. At the point A2, the value is what? 10. At the point, this one, point P, this is the value of z. And at the point B1, this is the point. Now, which one is maximum out of these 4? 0, 10, 235 by 19, and 9. Obviously, this number is what? This one is the what? Maximum one. And at which point you are getting? You are getting what? At the point what? This one. So, clearly, z is maximum at this point. Hence, x is equal to what? X is equal to 20 by 19 and y is equal to 40 by 19. Is the optimal solution of what? Is the optimal solution of the given LPP. And the optimal value is what? Of the z is what? 235 by 90. So this is. Is that clear to all of you? And if you get disconnected, so please connect once more, okay? Because after 2 minutes you will get disconnected. So just you see this next problem, this example 4. So in this problem, you need to maximize and minimize this problem. And this is your constraints. So here just you see, it is given what? 3x minus 4y plus 12 greater than or equal to 0. So first you need to, what you do? 3x minus 4y. Constant terms you need to write in the right side. 3x minus 4y. It is plus 12, so take it to the right side. So it will be greater than is equal to what? Minus 12. So what you need to do, make the constant term positive. So in order to make it positive, you need to multiply it by what? Minus. So it will become what? Minus 3x plus 4y. Now, since you are multiplying by minus, so this greater than equal to sign will change to what? Will change to what? Less than is equal to. And this is minus minus plus 12. Do you know that or not? If you multiply by negative sign, so this greater than sign, if the greater than sign is there, so that will be changed to what? Less than is equal to. And if less than is equal to sign is there, and if you are multiplying by minus, then that will change to what? Greater than equal to. That opposite. Similarly, you need to write this all in equations. So the next one is your what? It is 2x minus y greater than is equal to your minus greater than is equal to what? Minus 2. So minus 2, then what you need to do? Multiply by minus. So it will be minus 2x plus y. And that will be less than is equal to 2. Make it positive. Similarly, that is already, it is 2x plus 3y and minus 12. Take it to the right side. So it will be greater than is equal to what? 12. Okay. So this is the inequations. Our inequations are this one. This is the first one. And this is the second and third one. So we have 3 inequations here. And then another one is what? X is equal to 4. X less than is equal. So what you need to do? Make it make this inequation as equations. Convert this inequation in terms of what? Equations. So then you have to remove this less than is inequality sign by what? Equality sign. So you will get what? 3 equations here and the other 2 equations from here. That is what? X is equal to here, from here x is equal to 4 and from here y is equal to 2. So total we have 5 lines. 1 here, 2 lines here, 3 lines and these 2 lines, 5 lines. So draw these 5 lines on the graph and then find out the solution region of what? Each lines. And then from there you find out the common region. And after getting the feasible region, that is common region, you find out all the corner points. And then at each and every corner point, find out the value of what? Find out the value of z. And since the problem is both maximization and minimization, what you need to do? Check for what values of x and y, the value of z is maximum, and you check for what values of z, for what values of x and y, the value of z is what? Minimum. And that's over the problem. That solves our problem. So that thing has been done. So here it has been not changed. If you change, then also okay. If you not change that, if you change, then that will be becomes more easy. Here it has been not changed. I have shown you. If the constant term is negative, so make it positive by multiplying minus n. So that will be better. If you do like that, convert the constant term into positive, then it will become easy for you. So now the next part is what? So now see here. Now we find out the solution region. The first one was what? 3x. Now, if you'll see this one also, so just to see. Now if you put x equal to 0 and y equal to 0, so 0, what is here? Greater than is equal to what? Minus 12. And if you see the what I have taught you, this you have to just to change the sign of this constant term. So it will be minus if you multiply by minus. So minus 3x plus 4y less than is equal to 12. So meaning is same. Now obviously 0 is greater than minus 12. Obviously 0 is greater than what? Minus 12. So that means the solution region of what? This contains what? Contains origin. Similarly, the next one is what? 0, left side 0, greater than is equal to what? Greater than equal to minus 2. Greater than equal to minus 2. So obviously this is also true. And so the solution region of this inequation also contains the origin. Next, if you put x equal to 0 and y equal to 0, so left side will be 0, greater than is equal to what? 12. Greater than is equal to what? 12. And this is not correct because 0 cannot be greater than 12. So in that case, origin will not lies in the solution region of what? This line. So in the solution region of this line, origin will not be there. But in the solution region of this two line, origin will be there. Next, if you put x equal to 0 here, so 0 less than is equal to 4. So 0 is what? Less than is equal to 4. And so origin or in the solution region of this line, origin will be there. Origin will be there. And next one is what? Y greater than equal to 2. That means if you put 0, then what? 0 greater than equal to 2. So, but the solution region of this line. But this is not true. 0 is can never be greater than equal to 2. So that means the solution region of this line will not contain any origin. So these two inequations in the solution region of these two inequations, origin will be there. Here origin will be there in the solution region of this, but this inequation and this inequation, that means solution region of this and this, origin will not be there. So after finding the solution region of each and every line, you will get a common region, and that common region will be what? In each and every solution region. So that will be the common region. So after finding the common region, you will get the what? Corner points. And then just to find out the value of z at each corner points. And then since the problem is of maximization and minimization both, maximize or minimize, whatever you need to do, just to check from there. If the problem is of maximization, then you find out the values of x and y for which the value of z will be maximum. That will solve our purpose. And if the problem is of minimization, then you find out the value of x and y for which the value of z will be what? Minimum. So this is. So if you see, so this is the graph. So this was the line y equal to 2. See, this was the line. Your condition was given no here. Y greater than is equal to what? 2. So you have checked whether the solution, so y equal to 2. The line will be what? Y equal to 2. So this is the line. This is the line y equal to 2. So here, if you have to check whether the origin lies in the solution region of this line or not. So if you put 0, x equal to 0 and y equal to 0, so left side is will be 0, greater than is equal to 2. Greater than equal to 2. So this statement is not correct, and so the solution region of this will not contain any origin. So in that case, the solution region of this line will be where? Which part will be the solution region? Obviously, the below the line, whatever the region will be there, that will not come, because below the line origin is there, but in the solution region of this, origin will not be there. So obviously the solution region will be what? The above the line. This is the solution region of this line. Similarly, there was x less than is equal to 4 was there. X less than is equal to 4. This was the line. So which, that means x is equal to 4. So x is equal to 4 is which line? This line. X equal to 4 is this line. So x equal to 4. Now if you put, then you need to check whether the solution region of x equal to 4, whether origin lies or not. So just to put x equal to 0 and y equal to 0. So x equal to 0. So 0 is less than is equal to what? 4. So this statement is true. That means the solution region of this inequation contains what? Origin. So obviously this line, this line. So obviously to the left, if you take these regions, origin is where? Origin is here. Origin is here. So obviously the solution region will be what? To the left of this line. To the left of this line. The right region will not be the solution region, because in the solution region of this line, origin will be there. So the solution region of this line should be what? This side, to the left of the line. To the left of the line. Similarly, you find out the solution region of what? Each and every lines. Find out the solution region of what? Each and every lines. After getting the solution region of each and every line, you find out the common solution region. You find out what? The common solution region. Now see, if you check these points, these parts, these parts. So this part is the common region. This region is in the solution region of each and every inequations. Okay. Now, after getting the solution region, you need to find out the what? You need to find out the corner points. So this is the corner points one. This is the another one. Here it is another one. Here it is another one. Here it is another one. So total how many? 2, 4, 5. 5 corner points. So 5 corner points. Just you find out the 5 corner points. Just you find out the 5 corner points. And after getting the 5 corner points, you need to find out the value of z. So now see here. Just to see. These are the 5 corner points. And you know, obviously you know how to find out the corner point. If the just to check which 2 lines are intersecting. So if these 2 lines are intersecting, just to solve it, you'll get the corner point, intersecting point. So then we have got accordingly at each point the value of z. Okay. Then if your problem is of maximization, then you check. So which one is greater? So obviously out of this, the minimum one is this one. And which one is the maximum? Maximum is, this one is the maximum one. This one is the minimum. And this one is what? Is the maximum one. So that means at the point P1, 3, 2, at the point 3, 2, the value of Z will be what? Minimum. And at the point 4, 6, the value of Z will be what? Maximum. And that solves our problem. And that will be the solution. Okay. So there are several problems here. Just to go through that one. And I think their solutions are also given, just to compare with that. Then there are some other types of problem, diet problem. So cost is there. So the problem is of minimization. Diet problem already have discussed. So cost problem, so it has minimization. So since it has been given in the tabular form, so first you need to convert it in terms of what? In its mathematical form. So after converting it in its mathematical form, so this is the mathematical form. This is the mathematical form. And then continue the process as we have discussed. Graphical method, just draw each line over the graph, find out the solution region, then find out the common region, and after that find out the corner points. And after getting the corner points, find out the value of Z. And then since the problem is of minimization, then you find out for what values of X and Y, the value of Z will be minimum. And that will serve your solution of the given problem. That's very simple. So like this, there are many problems. Just to go through this all. If you find any difficulty, so you can ask me. There are some more problems are here. Just to go through that. The solutions are also given. And find out whether you can able to solve or not.